For this next part of our coastal study, we're going to be looking at waves. Waves are really important because, of course, they move a lot of sand along the coast, but also they are responsible for shaping the coastline. Now, waves in the ocean are just like waves in physics. We can define a wavelength, a wave height, and a crest and a trough in the same way that you did in light waves or any other waves that you studied in physics class. One of the interesting things about water waves is that the water molecules themselves move in circular paths. They don't move towards the shore like the wave does. The individual water molecules move in these circular paths that you see here. And at the surface, those circles are much larger, and they get smaller as you get deep. And in fact, the important point about this is that by the time you get to a depth of about half of the wavelength, the individual water molecule movement has stopped. And so that half wavelength depth is the depth below which the water is not moved by the wave. And that's important to know because it has a lot of useful information to it about where the waves break in connection with the shoreline, and also just for the future, in case you ever happen to be scuba diving and you're on a boat and it's really rocky, get in the water and get down, and you'll get underneath that moving wave. Now, the size of the wave is really a function of the wind, because waves are caused by wind. And so 3 things about the wind determine the size of a wave. The first is the strength of the wind. If you have a very strong wind, as you might imagine, you're going to get bigger waves. The second is the duration. How long has the wind been blowing? If it just came up, the waves will be kind of small. If it's been howling in the same direction for days and days, the waves will be bigger and bigger. And then the third thing is fetch. And fetch is the area over which the wind is blowing. So if the wind is coming, as you might know up in North Texas, that long howl across the wide prairie, that gives you pretty darn good wind, doesn't it? Same thing if you're an island in the middle of the ocean, where the fetch is very long, the wind has a long direction to blow over, the waves get bigger and bigger. So Hawaii makes much better surfing than Texas. The Gulf of Mexico is a pretty small body of water compared to the Pacific Ocean. Now, what causes waves to break? This is where our little circles of movement come in again. Out away from the shore, the water movement just moves, as we described before, in these small circles that get increasingly smaller as you go down. But as that wave gets closer to shore, you get to a point where the wave motion interacts with the shoreline bottom. And when that happens, the moving water that is in contact with the ground slows down, and therefore the top starts to tip over and eventually break. So the distance where that happens is where that magic half wavelength depth is the water depth. That's where the waves begin to swell and then ultimately break. Now, the other shoreline process that's really tightly connected to waves are tides. And you guys have learned about tides before, so I'm just going to remind you briefly that tides are a function of the gravitational pull of the moon. And that gravitational pull pulls the water into a bulge towards the moon and an opposite bulge on the other side of the Earth away from the moon. And of course, Earth is spinning, and it takes 24 hours to turn around in this bulge of water. And so any place you happen to be on Earth is going to pass through a high tide every 12 hours and a low tide every opposite 12 hours. So high tide, low tide in 24 hours, just about 6 hours apart. Now the moon, of course, is also moving, so it's slightly longer than 6 hours. When we talk about the tide going in and the tide going out, this is a very extreme example from the Bay of Fundy, where the difference between high tide and low tide is extreme. the water does seem to go in and out from shore, but really what it's doing is it's coming up and down. And when you're in a high tide situation and the ocean is deeper, it obviously floods onto the land farther. And so that's what high tide and low tide are. And individual shoreline differences are what cause that tide to be really extreme like it is here, or maybe much less noticeable like it usually is along the Gulf Coast. And we pause here.